Good evening. What we're going to illustrate tonight is limits that do not exist because the values oscillate. We're going to take a simple graph, the graph of y equals the cosine of 1 over x, and then what we're going to do is we're going to see why does it oscillate. I'm going to try to find the limit as x gets closer and closer to 0. First thing we want to do is just look at the general graph. So if we look at the general graph, you can see right here in the middle of the screen, the graph, as it moves closer and closer to 0, seems to go in this kind of zigzaggy pattern. It's going up and down. It looks kind of confusing. So what I'm going to do is I'm actually going to zoom in. Let's kind of stretch the graph out a little bit in each direction and move the graph. I'm going to continue to move the graph out. Now notice what's happening. As I move the graph out, I'm going to make 2/10 my new negative value, negative 2/10, and I'm going to move the positive value of x up to 2/10. Now do you see what's happening to the graph? It's actually continuing to oscillate. As you move closer and closer to that value of 0, it's oscillating faster and faster. Well, why? Because the cosine of a large value tends to keep going up and down, and the values are getting larger and larger as x approaches a very small fraction. 1 over x is a very large number, and we're starting to go through numbers rather quickly. As you get to 1/1,000,000th, you're up to 1 over 1/1,000,000th is a million. And then one small change actually runs through a lot of values. So if I push this graph out again, so where I can see closer, even closer to the middle of the graph where x is approaching 0, what I have is I have a very strange effect of where the graph is going faster and faster and faster up and down. So, is that value going to one specific value? No. It goes on and on, up and down, closer and closer to 1 and negative 1 and 1 and negative 1 and 1 and negative 1 and all the values in between. So that's why the limit fails to exist at that point. So, thanks for joining us. That kind of concludes our video for tonight. Okay, thanks.